So let's discuss about the design flow. There are many standard tools available in the market by the various tool vendors for the electronic design automation. The figure will shows the complete VLSI design flow of the PLD design tool. Here I will show enough slide. This is the figure of the design flow. The different steps involved in a design flow are follows. First one is creating a project. Steps involved in VLSI design flow are as follows. First one is creating a project. Second one is design entity or design entry. Third one is functional simulation. And third one is synthesis. Assigning the circuit inputs and outputs to specific pins of the PLD. And the sixth step is implementation. And the seventh step is simulating the design circuit for area and time constraint. So simulating the design circuit for area and time constraints. And eighth one is programming and configuring the design on a chip. Programming and configuring the design these are design flow. Let's see design entity. This is all about the design flow. This is the figure of the design flow and these are the steps involved in the design flow. So let's discuss about the design entry. The design Entry is the first step in the design of any VLSS circuit using EDA tool. In this step, the intended design is entered on the personal computer, and the figure will be shown in the next slide of the various way of the designing entry, and the various way in the design entry are shown below the diagram. So let's see the diagram of the design entry. What are the ways of the design entry? This is the design of figure of the way of design entry. The various way of the design entry we will see. First one is schematic entry. First one is schematic entry. Second one is design entry using hardware description language. Design entry using hardware description language and using finite state machine and FEDIF entry. So let's see one by one. What is the schematic entry? The schematic is the design developed by the digital designer using different logic gates and the logic ICs. Schematic can be drawn on the monitor screen by using a CAD tool. In this entry, the designer first designed the equivalent digital system using KMap, and instead of the implementing the design on the board, the design can be tested using simulator. So second way is design the entry using HDL. The hardware description languages originally developed for the circuit modeling. Nowadays, these are used for the complex hardware design. In this, the design is represented in the form of coding template used by using the syntax of the HDL, and the different HDLs used in a practice are VHDL, ABL, and Verilog. The finite state machines, the design can be entered using state diagram of the sequential circuit, and the CAD tool can be used to draw the complete state diagram on the personal computer and simulated for the required result. Nowadays, the EDA tool are available which will convert the complete state diagram into the HDL code, and this HDL code is further processed. Then next is EDIF entry is the electronic data interchange format, an industry standard file format for specifying a design net list. It is generated by the EDIF design tool entry tool, which having the first input file, VHDL file Verilog. The VHDL extension is .vhd and .vhdl and Verilog is .v, and ABL file is nothing but .abl and .abv. IDIF file which having extension .edf, and the schematic file which is having .sch, state diagram file having DIA, and user constraints file is .ucf, or the user generated in a particular entry editor. The output files, the VHDL file .vhd, .vhdl, Verilog, .v, and this ABEL file is .abl, and EDIF file having .edf, schematic file .esch, state diagram file DIA.asf, user constraint file is .ucf. These are the EDIF entities. Then next one is functional gate level simulation. So next topic is the functional or gate level simulation. Functional or gate level simulation. Functional gate level simulations are carried out to test the designs entered in the design entry tool. The design are tested by the applying test inputs or outputs are checked as per the specification. The importance role of the simulations is to be find the error in the design before the design is implemented in the target device. These simulations are mainly carried out initial stage of the system design. So let's see about the next compilers and synthesize tool. Compilers and synthesize tools. A typical CAD software package contains several components and analyze in the first step in the synthesize flow. In this stage, the HDL code is checked for the syntax errors, and the logical simulations is the process that decreases the area or increases the speed of the design. Normally, the system designer develops the HDL code and synthesize tool identifies the syntax errors. Here, this is the figure which shows the synthesis processes. The synthesis processes also creates the netlist. Netlist is the description of the circuit developed by the HDL code, and netlist is a basically contains the connections or connectors instance and the connected signals and assigning the constraints. The design constraints is a subset of the value of the type and the set of the possible values for the object of a given type that can be subjected to the conditions is called a constraints. The file containing the information about the pins, their directions, and the log pin of the selected hardware devices is called as a user constraints file. Before implementing the design on the actual device, this file is required with the select and particular functional block and configurable logic block on which the design to be loaded. So after that, we have to see the implementation. In this step, the design is implemented on the device. A library containing the design unit in which a given component is declared is called as a target cell library. The target library is used to determine the visible entity declaration under the certain circumferences for the default binding indication, and the different steps in the implementation are as follows. The next one is netlist translation, a program that converts all the input result into the single merged file, and mapping of fitting. Mapping